It could be a slope. When I'm looking at those 2 points of that line, I could be looking at the limit of the slopes, right?
Predictable point that you'll reach as you go towards the first.
Exactly. Yes, exactly. It's a predictable y value or a predictable f of x value, right? The height. The easiest way I want to say it. It's the height. If I can plug in, plug in. If I can't plug in, right now I'm looking to expect an indeterminate form, right? I'm expecting to find an indeterminate form, and that means a 0 over 0, or an infinity over infinity. That comes later. An infinity minus infinity, believe it or not, that's not always 0. We're looking for this form. Right now it's just our 0 over 0, and then we're trying to find a replacement function. Right? You with me? I can double check it numerically with a table. I can double check it graphically, right, with Desmos, both with Desmos. So let's do a bunch of those today. Here we go. Let's do the limit of x plus 2 over x cubed plus 8 as x goes to negative 2. So first of all, can I plug in? Well, I'm going to try and plug in every time. Try to plug in, that's what I want to do. If I plug in upstairs, I get negative 2 plus 2, 0. Downstairs, I get negative 8 plus 8, that's 0. So I get my 0 over 0. So I know I'm trying to find my replacement function. What about this definition? What about this definition of saying I can replace this function with a new function? What about this definition that says I can replace this function with a new function? What is my value of c here that's giving me an issue? Yeah. Yeah, so what value of c is my issue? Right, remember our definition of our limit. This is the formal definition, right? This scared everybody last class, right? We said that the limit as x goes to c of f of x equals L is equivalent to this whole horrible thing, right? But what is telling me that I can replace this function? What piece here? What's my c value? Negative 2. Do I care about getting to negative 2? What's telling me I don't care about getting to negative 2? Not the absolute value. The absolute value is telling you left and right. Right? Check from the left, check from the right. What's telling me I don't care about getting to negative 2? Yes, but it has to be bigger than 0. I can't, if I say x minus a negative 2, x plus 2, and I put the negative 2 in there, I get equal 0. I want to make sure I'm never actually getting to the wall. I'm never actually getting to c, but I'm making a prediction about it. So if I can get a function that I can just plug in, I can just replace this function with my new function, and that's what I'm trying to do, right? So I like to say that this is the limit as x goes to minus 2 of star. And then I like to work on star. Star is my original function. And I want to factor that. Does anybody know the factoring from memory? So it's an x plus 2 x squared minus 2x plus 4. Now, I could either have this memorized. Question?
I don't think so. Let me double check. Okay. So I like synthetic division here. Obviously, -2 is my 0, and I'm checking it into 1x cubed, 0x squared, 0x plus 8. I'm going to bring down the 1 and multiply, and then add, and multiply, and then add, then multiply, and then add. So you see I got the 0, and look at the coefficients here matching up. There's a 1, there's the -2, there's the +4. So this star becomes 1 over x squared minus 2x plus 4. Is everybody comfortable here? Is everybody comfortable? Anybody not? Question? Say it again for me, one more time.
I said, I just like mapped it out, like.
Yeah. I'm going to do it another way, okay? So, I mean, this is the sum of two cubes. If you remember in algebra 2, you factored that, right? If you couldn't remember it, you got a tattoo, right? That's not cheating. If you go to that level, I'm joking. But so I did it with synthetic. Let me show you also with. So anyway, this is my replacement function. Can I plug 2 into here? Can I plug the -2 into here? Yes. So as I'm doing this now, the limit. Say again? Okay, that's okay. Yep. So that limit of star is the limit as x goes to -2 of 1 over x squared minus 2x plus 4. And when I'm plugging in, I'm no longer taking a limit. I'm at the wall already. I know the height I'm going to get is this height. Right? Is that making sense? See, I don't have limit written anymore. And this is what? 1 over 4 plus 4 plus 4, 1 over 12. I want to show you how I check that and how you will check it on your first quiz. Right? So I'm going to Desmos. What's the difficult part so far of this problem? Yeah, question? Yes. So what I'm doing when I do synthetic division is I put in placeholders for the 1x cubed term plus the 0x squared term plus the 0x term plus the 8. So I don't put in any of the x's. I just put in the coefficients.
Oh, you did that 8 because it's 8.
Yep.
Oh, it's 0. Oh,
Yeah. So if you haven't done synthetic division in a while, it's fine. I'm going to do long division next. Okay? Just do a quick recap of it. Let's check how to check this. So Desmos, everybody. I'm going to graph the function. What did I have? X plus 2, all divided by x cubed plus 8. Just with the shift key and the arrow key, or you could use the mouse. Right? You could highlight with just the mouse, and then hit divide. Yep. Nice. We found our point, which we think is our answer. At -2, we got what? 1/12. Yep. And I'm just trying to say, hey, does it look right? So there's my graphical check. I got it right. Right? And also, it's nice to look at my replacement function. What did I get? Y equals 1 over x squared minus 2x plus 4, right? Take a look at the replacement function. You see, if I highlight and unhighlight, you see it's right on top of the original function. But the original function has a domain of, I can't use -2. The replacement function has a domain that I can use -2. Right? Is that making sense? Because it hit right on the graph, right? So we can also check numerically. And so we're going here to this to here. And we're going to put a table on this first function. I'm getting really close to -2 from the left and from the right. So what number am I at from the left? So I want to be left of -2, right? -2 point, yes, -2.1. It's okay, you'll get used to it. -2.01, -2.001, and you'll probably see that this 0.083 is not going to change much now. -2.0001, and of course I want to check it with 1/12, right? Yes, you with me? I should check from the right. It's obviously going to still be the same from the right. But from the right, I'm looking at -1.99, right? -1.9. Oops. -1.99. -1.999. Easy, right? And you could start to see that my 3's are just going to get pushed, right? I know the answer 1/12.083 forever, 3 forever, and see these 3's are going to push to the further. Not so easy to think about just gas station money on this one, because I had to look at the decimal 1/12, right? But remember, it's like a crime scene. There's a math problem on the board, the teacher's dead, right? You're trying to figure out what happened. Well, we better figure out the problem first. Nice, let's do another limit. Oh, you want to do that one with long division? Yes? Long division, how many are comfortable with the long division? Beautiful, long division is better than synthetic. Long division will always work. Synthetic only works if you're dividing by a linear. Question? I didn't do it yet. So I'm trying to come up with a replacement function again. This time, instead of synthetic, I'm going to do long division. So I'm going to take x plus 2, long divide into x cubed. Oops, sorry, wrong symbol. Plus 0x squared plus 0x plus 8. And I'm asking myself, x times what will get me to x cubed? Good, x squared. And then I come back and multiply to each term. So I get x cubed plus 2x squared. I change my signs and add. The first term will always drop out. So now I have -2x squared plus 0x plus 8. Rinse and repeat. Right? Keep going. Yes? So what am I asking first? X times what will get me where? To -2x squared. That's -2x, right? Then I come back and multiply. So I get a -2x squared minus 4x. Change my signs and add. So I get 4x plus 8. Rinse and repeat. What number do I need? A 4, right? Multiply 4x plus 8 and change the signs and add, and I get 0. So there's my other factor. Is that more comfortable for some of you? When I ask you to do a limit algebraically, I'm just going to say factor. So I don't care if you know the factoring or right, this class is not about factoring. I don't care if you use synthetic, long division, you got to do something though, right? So again, make sure you look at all my old quizzes from chapter 2. They're in that chapter 2 folder, right? Good, let's do another. So I did a factoring one on Monday. I did another one today. I want to do some, if you remember, I had 3 types, right? I had what? factoring, question?
It was supposed to be zero. Oh, no.
You got it? Yep. When I came back and multiplied, yes. Go ahead, David. Change my signs and add. Yep. Yeah, so I didn't change my signs because I knew it was obvious that they were going to cancel. Again, our three types of algebraic limits. I might have to factor. I might have to find an LCD. I might have to use a conjugate. I might have to use two of those in combination. I might have to use all three of them in combination. I put them in the order that I want you to try and do them. A question? Yeah. Least common denominator. Yep. Or GCD, a greatest common, just a CD, a common denominator. It might not be the least common denominator, but it doesn't matter. Okay, you ready for an LCD problem? So here's my function, and right away I want to look at what happens when I plug in. Because if I plug in, I'm done, right? If it works, right? So it's going to get 1/3 minus 1/3, that's 0, that's 2 times 3 is 6 minus 6, that's 0. Indeterminate form, right? So we know we want to come up with a replacement function. I like doing this so I don't have to keep writing limit. I'm just going to work on star. Star is what I'm calling this function. In this case, I'm going to get an LCD by taking all my interior denominators and multiplying them together, and then taking that LCD and over itself, so it's a 1, right? So you know where I got the 3x from? Yep. So then I'm working on this. I get 3x over x minus 3x over 3, all times 3x times 2x minus 6. Everybody with me there? I'm distributing that to my numerators. Yes, question? Yeah, that's what's supposed to happen, and it will. It will. How did I do that? I just took my interior denominators. So when I'm saying interior denominator, I'm saying there's an x, it's a fraction within a fraction. There's a 3, it's a fraction within a fraction, and there's a 1. Right? I'm taking all my interior denominators and multiplying them together. So now what happens, here the x's cancel, here the 3's cancel, and I rewrite. I'm trying not to be in a rush. What do I get? I get 3 minus x over 3x times 2x minus 6. But I can factor a 2 out there, can I? Yeah, so I get a 3 minus x over 6x times x minus 3. My teacher made me factor out that leading negative upstairs. So I get 6x times x minus 3, and now my x minus 3's cancel. Everybody okay here? Am I going too fast? Okay, I'll slow down. I don't mind. I'm not in a rush. I'd like to say I'm Polish, not Russian. But even if you're Russian, it still is funny. I'm Russian, but not Russian. Where? On which line are you at? On 5, I simply, remember I took, there's a leading negative I could factor out here. So you see here, if I distribute, I get back to that line. I get a 3 minus x if I distribute that negative back in. I get what I had here, right? And then I'm canceling the like factors. Right, I got an x minus 3 upstairs, I got an x minus 3 downstairs, they cancel. The question is here, can I plug in 3? Right here in line 5, can I plug in 3? Yes, but what do I get? 0 over 0, so I know I'm not at my replacement function yet. If I still keep getting that indeterminate form, there's more to do. But then I notice I can cancel those x minus 3's and I get a negative 1 over 6x. This is now my replacement function. Can I plug in the 3 there? Yep. So the limit as x goes to 3 of star is negative 1 over 6 times 3, so negative 1 over 18. I can check it 2 different ways. Whichever way you're more comfortable, I think it's the right way to go. For me, it's graphically. I know if I plot this function and I get that 1 point there, it will be true. Yes, question? Yeah. You can, I don't. I'm too lazy. It's on my page, right? I know this whole thing is my problem. So I'm kind of connecting that first line here with this line here, right? See it? Here's the original, which is equal to the limit of star. I did all the work with line star, and then I said, okay, well, that limit of star, which is equal to the original, by the way, gives me that height. I don't mind if you do that, right? I don't mind if you put in perfect English and punctuation and all of that. That's what most textbooks would have. But I'm saying, hey, like, some of our problems are form to the form. So whenever we can take shortcuts, let's do it. Yeah. Sure. Did the same answer to me? Yes. They both work. They both work. So if you didn't learn complex fractions in pre-calc, your tendency is to get an LCD and then you change flip, and that still works. It just takes time. If I say to you, find this limit using an LCD, and you do the keep change flip, I'll probably take points off. So make sure you can do the LCD. Question? One more time? It won't be. It won't be. It's going to be an arbitrary function. So you're saying that x, even in the original problem? Yeah. If I can just plug in, if I can just get the height, get the height. So, kind of what yeah. And what is allowing me to switch the functions, this original function has a domain of everything but 3. My new function has a domain of everything but 0, right? But the point is I have to plug the 3 in here. Say again? In the original, I can't be 0 either, right? The domain is not 0, not 3. Let's take a look at this one on Desmos. And you'll see where the 0 is an issue. So y equals 1 divided by x minus 1 divided by 3. Holding the shift key down, I'm using my arrows to highlight divide by 2x minus 6. You can see where the 0 is an issue, right? Yes, you agree? I put in my replacement function. Still an issue, 0, right? But not the point 3. 3 is fine. 3 comma negative 1 over 18, was it? Pretty cool, right? Easy. Nice. Let's do. Yes. Simplifying it. And if you see what I'm doing when I'm trying to find that replacement function, I'm asking you, hey, plug into 3 again. Can you? No. Can you do it here? No. Can you do it here? No. Until you can do that, I don't want to use the function that I have. I want to try and find that new function. Nice. We'll do a couple more with fractions, but let's do one with a radical. And anytime you need to take a picture of something, anytime I'm going too fast, please slow me down. I am your Uber driver. Don't wait till I get you home, and then you give me a low rating and say he drove too fast. Tell me to slow down, right? I hate when I'm speeding home, and I'm always speeding. I'm speeding home, and a cop is following me the whole way. I get to home, he knocks on the door, and he gives me 12 tickets. That's not right. Give me 1 ticket. Get me to slow down, right? All right, conjugate. Let's see. The limit as x goes to 9 of let's see, square root of x minus 3 over x minus 9. That sounds good. So nice and simple. So, can I factor anything here? This one I could factor out of that x plus 3 and that x minus 3. I could factor and be done. But the main thing I'm saying is I see a radical. And when I see a radical, I want to use a conjugate on this. So this is a limit of star, right? And star, I'm going to work on using a conjugate. So I want to multiply by 1, and I'm going to use that by getting the conjugate over itself. Is that making sense? Conjugate. My teacher would ask me the question, and they'd say, what should I do? And I yell from the back of the room and say, conjugate on with it. Question. Yeah, well, I want to plug in first, right? I want to plug in first. So square root of 9 is 3. 3 minus 3 is 0. 9 minus 9 is 0. I get 0 over 0. I know I'm using trying to find a replacement function. No, it could be the quantity of the denominator. In fact, you could have radicals in both. It's just that no one's ever told you what a cat or a dog is, right? You were like me growing up, I'd say, oh, look at that weird looking dog, and my dad would smack me and say, no, that's a, what's the cat? Yeah, the Sphinx, right? So, same thing here. If you do more and more problems, you'll realize, oh, I didn't need to simplify this. I didn't need to simplify this. I don't want to spoil the factors. Exactly. Yep. So in this particular one, because I know I'm trying to get rid of that piece upstairs, I am going to distribute up here. So I get square root of x, I get 3 square roots of x, I get minus 3 square roots of x, I get minus 9. And of course, that's why we use the conjugate, because those middle terms always cancel. Oops, sorry. Square root of x times x, square root of x is just x, sorry. So I've got now x minus 9 upstairs, factor of x minus 9 downstairs, and a factor of square root of x plus 3. How are we doing here? Speed's better? Too fast? Okay, slow me down, please. Don't let me go too fast. I'm not in a rush. Even one semester I had 3 snow days and I still got everything done that I needed to get done. Conjugate, so if you remember a plus b times a minus b, those are conjugates. And we always got a squared minus b squared. So those middle terms dropped out. It is well, no, I mean, we can give it a name if you want, but it's just change that middle sign. Nope. The name I'm going to give it is change the middle sign. Yeah, so I'd rather just say conjugate. There we go. Yes, exactly. Function radical x minus 3. I said I'm going to put for a conjugate. So I got my conjugate. The minus 3 turned into a plus 3. So I got radical x plus 3 over itself. Why? Because now I'm multiplying by 1. Multiplying by 1. That's what I can do. I can multiply by 1 and add 0. So now, can I plug in 9 here? Nope. Okay, can't plug in 9 here. But I finally do have my replacement function of 1 over square root of x plus 3. And there I can plug in 9. Almost. So the limit as x goes to 9 of star is 1 over square root of 9 plus 3. Yep. That's okay. I like the thought. Usually when we're doing things in our head is when we get in trouble, even in real life. So we want to try and put everything on paper so that you're communicating with me what's going on, right? And then you can double check yourself. I can double check this 2 ways, numerically on this one, graphically on this one. You will always know on these limit problems whether you're right or wrong or not. The key is to not panic when you know you're wrong. What I'll say is, it's usually best, you can look at your paper, but most likely you won't see it. Start over. New piece of paper. Nice and slow. Right? Organized. I'm going to teach you how to know you're right of every single problem. Again, the worry is when you know you're not right. You keep your cool, or you lose it, right? You just pass it out. I don't care. Let's do a tough one, like the one you'll see on your quiz. How's that, right? And let me give you time to do it without me doing it, okay? Let's find the limit as x goes to 4 of 1 over square root of x minus 1 over 2 Keep it like that. On your mark, set, go. You see fractions within fractions? Clear the fractions first, get the LCD. Then you'll still have a constant use. Then you still have the actual use of constant. When you take quizzes for me or exams, you can use don't know what else to do. I also give you a one-page form that goes back, one page. So what was our LCD that we got? 2 rad x over itself, yes? Yes? Anybody start there? Good. Then I see I need a conjugate. Yeah, question. I did. So 2 to the numerator, this to the numerator, this to the numerator, this to the numerator.
Oh, so you don't multiply.
Right, right. That's right. And one of the things I want you doing when we're doing stuff like this is don't copy me. You should be doing the problem, right? Can we get there? Well, we're done today. I think if you don't have the textbook, you certainly can try and start doing limits in my chapter 2 review. Question? Yep. Nice.
Right?
Yeah, you don't have to distribute, so you can just put in your value now. Yeah, good. How we doing? We okay? So if you don't have a textbook, you can do all these problems over. You can also look in our class in the chapter 2 folder, past exams and etc. In the chapter 2 folder, there's some quizzes there. Quizzes with solutions and chapter review with solutions. Do the algebraic limit. Start doing algebraic limit quizzes. Right, okay. You all try it. You want to figure out what your website is. We do limits for those. 24. You need more, yes. So there's lots of, in that folder, I'm sure, lots of problems and answers. What's up? I don't know yet. So I think they're supposed to with you all on Friday. That's not good. I'll do what I can. Okay. Cool. Okay, good. You lost your square root. Oh no, you got it here. That's right. Did I do it wrong? Should be 4 times 4, right? 15. No, yeah.
Oh, sorry.
Oh, that's it. And your net, you should have a negative. Yes. So when you multiply this guy out, you got 4 minus x, but this guy is still an x minus 4. You see it? This one's still an x minus 4. They're off. Yes, I factored out a negative from the top one. Yeah. Good. I know, at first, but you just started doing it. Don't you get used to it. What's up? You don't have to do synthetic division. You don't have to. Long division will work with everything, synthetic won't. So if you're uncomfortable with long division, that's fine. Yeah, so algebraic, we had factoring, we had LCDs, we had all of that. It could be, you have to factor, and you don't know how to factor it, you might have to long division factor. So you can factor oil. Thank you.
So a lot of the people who can't get into the online textbook.
Yes, can we look down and see what's going on?
I sent out a message, but yeah.
Yes, good, yeah, of course. What's up?
Yes.
Oh, you're okay, you're okay.
Yes. That's fine.
Yeah, I'll be right there. Go ahead.
log in, try and sign into that.
On this computer it works. You know something with the
Oh.
but like so where do I go from there?
You hear that? On this computer it worked. It might be that computer. Let's switch.
Where do I go?
So go ahead, go to our class. You should be able to see your class.
It did the same thing? Log in. Wait, we're not website, are we? Yeah, website, right? Yeah. Log in.
Maybe I'll just
That's fine.
I'll leave
That's fine.
everything else.
Of course.
Thank you.
Oh, wait, no, this is what we. Oh, here, Oh, you lucky. Lunch is your next class? Lunch 101? So we might need this for going forward. So we're trying to. And then most of them, don't bother unless it's simple. So you say, well, when is it gonna be upstairs, when is it simple? You get it, you figure it out. And you just do enough problems. What happens? So, but there's no way around it. Yeah, so I'm asking you, if you see fractions, put it down. Make it a little helpful. You see constant, you see that radical. Otherwise, not yet. Show you problems that you do know. You can redo the problems in our notes today. You can do the problems on first and chapter 2, that are limits. You can do problems in chapter 2 review, help. We Blackboard in past exams and et cetera. Yeah, I'll show you.
So if I'm in Blackboard, I can see on the sidebar past exams. And everything we're doing right now is in chapter 2. So if I open chapter 2, I see old quizzes and I see my chapter 2 review. If I open the chapter 2 review, question 2 is algebraic limits. Okay? Thanks. All right, good. You're fine. You okay?
Early is on time is late. Go ahead.
Email on Monday.
Yes, yes, about the textbook, yes?
No, the about the class that I should take next.
Oh, yes, I gotcha. Here, let me show you.
Yeah.
In fact, why don't you log in, because we could print this stuff. Log in
Oh.
wherever you're sitting.
All right, good work. Yeah. Nothing. So in fact, you might know, I'll show you maybe the review and next class. And you're reading text you want to do. Look at it, look at it, take it to the website. Major doesn't give us what we want, it's just as good. So program, let's go to. Here, right there. Yes, the right. Go there. Here it is. So those are the classes. So, that's fine, that's fine, so you might have to, like, for me, I had to do a couple summers, to start before conference. You know what I mean? If you like, you just go to your level, you might have to do a summer. Okay. No, or with, yes, absolutely, that's a good one for winter, you know, it's not super calculating things. What are you doing now, you doing the 140 right now? No, not the engineering, the 140. Yeah.
I'm doing the 100.
Okay, now for English, yeah. Okay. Yes, aren't you doing the English 100?
Yeah.
And are you doing 10 now?
Okay.
Okay, so you're behind a little bit, but no big deal. You'll be able to, this summer, you'll be able to get a backup course. If you want to. For me, it took me 2 years to get out of English college. But that's your drive. Okay? Yeah, you're welcome. You can finish if you want.